Okay, we're going live. Welcome. My name is Greg Gloria from Nerd Soccer Media, and thanks for attending our seminar tonight, which is Get to Know About Printed Electronics. So I'll be moderating this session and also the question and answer period. So before we start, I want to do some housekeeping. If we could all mute the microphones, at least the people viewing it and interacting with us, not the speakers. I can also remind you for that later as we go along, and then you could unmute it during the Q&A session. So with this seminar, we hope to give you a glimpse of the printed electronics area and how to maybe train up for this up-and-coming growth area. And so let's go over the agenda. I'll be introing tonight's guest, Professor Malcolm Keif of Cal Poly, Graphics Communications Department, and Michael Ciesinski, the President and CEO of FlexTech Alliance. And each will speak about 10 minutes and then open up for a brief Q&A period about printed electronics or any questions you have for both Professor Keif and Mr. Ciesinski. So let me intro the next speaker. A little about Professor Malcolm Keif. Professor Keif has been at Cal Poly since 2001. He's been a passionate in printed electronics for a while, and over the last few years has been developing ways of training people and researching in this up-and-coming growth area, culminating the creation of the Printed Electronics Certificate Program as you see today, and the graduate program of Printed Electronics at Cal Poly. So anyway, Professor Malcolm Keif, take it away and tell us about printed electronics.
Great. Thank you, Greg. Hello, everybody. I thought it might be simplest, because I am an educator, to throw up just a couple of PowerPoint slides just to keep me focused, because like most educators, I jump around if I don't have a little bit of focus. So I'm going to go ahead and share my screen with you for just a moment, and okay, we should have that, and I'm going to go ahead and do this. Greg, give me a heads up if this is working.
Looks good.
Okay, great. So I just have a couple of slides here because it's sort of an easy way to give you some visual of what printed electronics is. So, what is the deal? The deal to us is that there are folks that are projecting that this is going to be somewhere around a $75 billion industry in the next decade. And it's really this movement in manufacturing that can fundamentally change the way we approach both product manufacturing and product development by printing conductive and dielectric inks in an additive processing model using fairly conventional printing methodologies. But I'm getting ahead of myself a little bit, because we like to use the term functional printing. And functional printing is really about the deposition of active materials. And so we're talking about the application of conductive, dielectric, reactive, sensing, barrier, optically variable, or other ink that provides functionality beyond graphic and readability. And this little movie trailer here, of course, from Minority Report, was a great movie. I thought, it's Steven Spielberg's sort of vision of what the future might look like in the case of, getting criminals before they commit crimes. But I like the technology, like you just saw there, which is this notion of, newspapers with changing content, or, Tom Hanks' character, not Tom Hanks, Tom, what's his name?
Cruise.
Thank you, Tom Cruise.
Thanks, Michael.
Yes, Tom Cruise's character. He goes into a mall, his retinas are scanned, and then content in these signage changes. And so while clearly that's Hollywood's vision of what the future technology might look like, to us it's interesting because it gives a little bit of a picture of where, in some ways, printed electronics could go. So broadly speaking, functional printing is used for depositing these active materials to create electrical patterns or components, or chemically reactive fluids, things that might be sensors or somehow do some sort of a scavenger or changing of colors, and then these optically variable sort of effects. And this little screen printing press here is one of the presses here at Cal Poly that we can apply some of these conventional materials and not so conventional active materials to different sorts of graphic packaging, things of that nature. So why printing? And the answer is, flexible. Flexible is in. Flex substrates are clearly the future. They're what we expect to see in many, many printed electronic devices. And what makes flex substrates work well is roll-to-roll processing. And printing clearly has a long history in working with rolls and depositing fluids onto substrates in roll form. And while there's clearly some limitations to print electronics, we think that this bodes well for a future of applying these active materials using fairly conventional printing equipment. And fundamentally, we know that two-dimensional additive processing just makes more sense than subtractive processing, where we're using basically a sheet form of a wafer that we're adding materials and then etching away those materials. So while I'm not naive and I realize that silicon fabrication offers much greater performance and reliability, and I'm sure Mike will talk a little bit about the hybrid approach that we see a lot of people interested in. We think near term that a hybrid approach is really going to be the right approach, which is to take printed circuits on flex substrates and what other printed components we can produce, that we have the scale to be able to produce, and then do surface mounting components in sort of a hybrid style approach to produce these novel, new, interesting sort of printed electronics components. And it's clear to us that the form factor is really what drives this idea of using flexible substrates that can be bendable, foldable, rollable to make some interesting sorts of things. So what we know in education that we need to improve to make this a reality is a lot of things. Better design and engineering, including novel concepts and better sort of approaches to circuits and that type of thing. We know that materials are really critical, and that's one of the things that have driven printed electronics in recent years is we've got much better materials. And by better materials, I mean more highly conductive and low temperature sintering so that we can apply these things and be able to produce them in sort of a low temperature environment. And part of that is the substrates, getting better substrates, and part of it is the better materials. And this research continues on. We've seen a lot of interesting things coming out with graphene-based inks recently, which have very high conductivity. And so there's some interesting things being done in materials. And of course, the third leg of the stool is better manufacturing approaches. And so at Cal Poly, where we're really putting our energy in this printed electronics and functional imaging program, is in sort of the design novel concepts, and then at the back end, better manufacturing strategies. And what I mean by better manufacturing is really finer feature sizes, better surface structures, that type of thing. So we're focused on additional sorts of research, and again, primarily focused on this idea of fine print features. And if you're not familiar with micron scale versus nanoscale, we're clearly in the micron scale. We're in the tens of micron scales realistically for printed electronics, but that continues to get in. We see improvement as the plate manufacturing gets better and the actual print processes get better, to where we can sometimes now get into the sub 20, maybe even sub 10 micron feature sizes and still get better reliability as well. At Cal Poly, we're particularly focused on different sorts of applications like roll handling technologies, better ink transfer strategies, plate resolutions, registration and re-registration methods, using surface energy patterning for self-aligning fluids, and just optimizing rheological properties to help fluids flow better to create these nice surfaces, the morphology that we're looking for. So I thought I'd finish my little section here by just talking about some of the things that are easy to produce in printed electronics. One of them is electroluminescence, and this, of course, are the type of active materials that basically emit light. And to just give you a sense of how simple they are, I'll show you a couple of things we've done here at Cal Poly recently. Before I get out of this slide deck, though, power cells are also very, very interesting. And although the capacity of these batteries are quite low compared to the batteries you might purchase in a store, as we move into this new world where we're talking about wearables and other sorts of technologies, I mean, being able to produce a foldable, rollable, bendable power cell could actually be very attractive. Photovoltaics, although they're very, they're not popular at the moment, I still think that this is an area that print electronics can play an important role in, to be able to produce PVs for outdoor applications or not so much outdoor, but just mobile applications where you're moving the PVs around, like you see some of the illustrations here. And the last two areas, sensors, we know are very a very interesting part of printed electronics, particularly related to the actual sensor component itself. Now, obviously, if there's some logic that has to go with it or some display that goes with it, that may be a hybrid approach. But we think that printing has a good role in the actual printing of the sensor, assuming you have the material development work being done. And of course, the area that everybody's interested in is the display area. And while printed electronics at the moment is not a great solution for the active matrix, the addressable displays, clearly for static displays and lighting, printed electronics plays a role. And you never know, in the future we might play somewhat of a role in low resolution addressable displays. So I'll finish this little slide here before I go back and show you a couple of things we've done here, and just say that, Greg, I know you're going to talk about this a little bit later, but at Cal Poly we're putting some emphasis in this printed electronics area, and we're offering 2 upcoming programs. And so we can come back to this slide and talk about it at the end, Greg, if we have time. But right now, why don't I go back and I'll just quickly show you a couple of things here. Got to get back to this, don't I? Just tell me. All right, so I'm back here. So just a couple of, these are just undergraduate projects, but interesting nonetheless. So here you can see I've got a electroluminescent display, big elephant, or that is an elephant, right? Yeah. And we've got, a printed PV here. We didn't actually produce this at Cal Poly, but we're working with some folks that are working on PVs. We're working with some folks right now on some power cells, a rechargeable battery project. Actually, Mike helped us with connecting that one. So that's printed electronics, and Cal Poly's involved, and we'd like to invite others to be involved with us.
That's great. Well, thank you. That was a great presentation, Malcolm. So anyway, well, like I said, we'll have a Q&A period at the end here, but let me introduce the next guest. That's Michael Ciesinski. A little bit about Michael. Michael Ciesinski is the president and CEO of FlexTech Alliance. FlexTech, based in San Jose, California, Silicon Valley, is a private-public partnership chartered with the building and of the infrastructure for electronic display and flexible electronics manufacturing. FlexTech sponsors and conducts a multi-million-dollar technology development program, as well as industry, technical, financial, and market information events. Since 1993, FlexTech has identified 160-plus projects and coordinated more than $150 million in federal R&D directed towards flat panel display and flexible electronics supply chain. That's pretty interesting. Industry cost share funds have exceeded 60% of the total FlexTech R&D program. That's pretty nice. As CEO of FlexTech, Mr. Ciesinski was instrumental in putting together the display industry on the investment community roadmap on the map. He forged partnerships and investment banks that helped with relationships with and partnerships with investment banks that help drive the industry's rapid growth. And under Mr. Ciesinski's direction, FlexTech successfully competed for the Nano Bio Manufacturing Consortium Award from the Air Force Research Laboratory. FlexTech also manages the Laser Illuminated Projector Association, which is interesting, a worldwide group of technology leaders in imaging products. So anyway, thanks for joining us, Michael. We know you have a busy schedule, but it's kind of important to get an industry represented at these kind of events that we hold here at Cal Poly. So thank you. So let's talk about some of the exciting trends in printed electronics that you're currently seeing from your point of view, from the Alliance's point of view.
Well, thanks, Greg. And geez, that was just an outstanding introduction by Malcolm. He gave me so many points to segue off of. I'm not sure where I can start first, but you mentioned we're headquartered here in Silicon Valley, and I think basically the question that a lot of people ask here in the Valley is, what if? That's really what's driven the Valley. What if you could do this? What if I could do that? What if we could do this together? So some of the questions we ask when it comes to flexible printed electronics is, what if you could remotely diagnose someone who is ill or chronically ill, and also remotely provide medication or treatment to that individual? What if you could immediately look at a package and with your smart device get a lot of information about how that product can work for you or maybe not work for you? And we talked a little bit about displays, Malcolm did. What if the display wasn't just a kind of a piece of glass encased in a bezel that we're all looking at tonight? What if it actually was the product, and it was flexible and conformable, it could fit inside your pocket and it wouldn't break, and it lasted more than 6 months? So these types of what-if questions really can only be answered, we believe, if you change fundamentally, in some respects, how you're manufacturing electronics today. We've all grown up with a wonderful base of silicon-based electronics in the integrated circuit industry and for flat panel displays on large sheets of glass. But to make something lightweight, conformable, rugged, wearable, that paradigm has to change, and we think the introduction of substrates, whether they're polymer substrates or flex glass that Corning is producing, even aluminum foil. As a matter of fact, Cal Poly's printed on paper. They've printed electronics on paper. If you can change that paradigm, if you will, then you really open up lots of different market opportunities. And Dr. Keif alluded to at least what one firm is referring to as a very large market opportunity. I think Malcolm mentioned close to $70 billion, which is pretty aggressive, but nonetheless a big market opportunity. We see the market opportunities in very specific areas, in medical, in sporting goods, wearable electronics. We believe is a tremendous opportunity, and these are all markets where significant companies are playing. Think of sporting good companies like Adidas or Under Armour or Nike. These are companies who are attending FlexTech workshops. Companies like Procter & Gamble, Colgate-Palmolive, American Greetings have attended or participated in our workshops in the past. All of them you don't necessarily associate with electronics. These are companies that are great in designing products, some of them manufacturing products. A lot of them are good in consumer goods. So what they are all interested in is how a new form of electronics, printed electronics, flexible electronics, is really going to impact both their product as well as the package that in which their products are sold. So we also not only see, if you will, a product play here, but we also see a very distinct play in the terms of packaging and packaging science and packaging applications. So the product and the package upon which that product is encased is going to contain more information. So again, you're going to have things called smart packaging, or whole conferences and workshops devoted to the idea of making packages smarter and able to communicate with the consumers. Recently, FlexTech conducted a survey among about 40 or 50 potential users of flexible printed electronics, and as I mentioned, we covered the sporting goods space and healthcare. Actually, there was a respondent from the insurance industry, very interesting application they came up with. But we asked them questions about, for example, when do you think flexible and printed electronics is going to be able to impact your market? And interestingly, about 50% of them said within 1 to 3 years. So clearly they are already working with people who can produce, at a minimum, prototypes. If you think about just the product design cycle probably being, in some cases, 6 months, but maybe even more, 18 months or 24 months, that means large manufacturers are already working with product designers to incorporate flexible printed electronics. Some of the unit volume that they talked about were not just in the thousands or tens of thousands, but a number of them talked about, if product were available, they would readily buy hundreds of thousands, if not millions of units. So again, I think this presents, for people who are interested in participating in Cal Poly's educational opportunities, the opportunity to develop a career path where you can be literally first on the ground, first to the market, with an educational background in flexible and printed electronics. And Cal Poly's historic learn by doing, I think, lends itself very nicely to whether it's the certificate program or, of course, a course and a degree program on campus, where you're going to be working with experts such as Dr. Keif and others on the faculty who are well known in this area. For example, one of the programs that we have underway is a sensor that will work on a motor and be able to tell you how that motor is functioning. Now, in many circumstances, airplanes, for example, and in some large fleet vehicles, they take vehicles offline, or they take apart engines at certain intervals, so many landings, so many takeoffs. That's not always efficient. Economists would tell you that, because the thing may perfectly work well for another 3,000 cycles, but you take it off because that's when you were told to take it off. But if you can put a sensor in there and you can figure out a way for that to work in a very tough environment, have it be recharged remotely, be able to grab that information, now you've got a very interesting product that can extend the life of a product, and indeed save some maintenance dollars. This is a type of work that Cal Poly has undertaken in conjunction with Berkeley and a couple of other organizations funded by our organization, FlexTech Alliance. So there is the opportunity to participate also in leading edge R&D, I believe, through this initiative. In closing, Malcolm mentioned a bit about there's printed electronics and there's traditional integrated circuit electronics. These come together in what people are now calling hybrid electronics, where you are bringing in the higher end semiconductor content with the ability to rapidly print devices, and literally bringing together the best of both worlds. And indeed, some people are even looking at additive manufacturing as entering this space as well, or 3D printing. So I really think I share Malcolm's enthusiasm. I think we're on the cusp of a whole new way to manufacture electronic devices. It provides a great opportunity if you're looking for new products, a way to get products quickly to the market, in a way to better understand, from an educational point of view, at least what Cal Poly is providing, a good background in printed and flexible electronics.
Wow, that was great, Michael. Yeah, thank you. That was incredible. I like a lot of the views and I think from your viewpoint is a really good viewpoint as far as the industry goes, because you're not only at the forefront, you also can see what the applications are. So thank you so much. I'm going to open this up to QA. We only have one student online, or one interested party here. Kenny, if you want to unmute your mic, and if you have any questions for either Professor Keif or Michael, I'd appreciate you answering them.
Yeah, I was interested in how the circuits, are they designed just like a printed circuit board, or are they designed using a different type of programming language or a different type of interface? How does that work?
Well, from our perspective, we're sort of agnostic in terms of the tools. We can take a Gerber file and we can image it in a PDF workflow. We can take a PDF file and image it in some sort of a plotting workflow. It really just depends on what you're trying to achieve. We've done both, so it can go any direction. I mean, we've used AutoCAD files. It doesn't really make a lot of difference. It kind of depends on what you're trying to achieve.
So it could literally be an image file. It doesn't have to be machine code or something like that.
Well, again, in the case of printed electronics, in many cases, if you're using a conventional sort of graphic printing model, we already know how to create and use vector files that are in PDF format. And so it's an image file. Now that's a little bit of another story, because then you're resolution dependent, and so it may or may not work if you're talking about a true bitmap file. But as long as it's a vector-based file, it doesn't make a ton of difference to us.
I guess it also depends on the resolution that you want to achieve, right, Malcolm?
Right. Exactly. Right. So, and that's a bitmap file is resolution, stuck. So you better have it right the first time.
Yeah, you're not going to have a micron scaled image like that, right?
Well, I mean, you can. Like in our case, we have an 8,000 dpi imaging device, and it does have to be ripped, and so it does have to be a bitmap at the moment that we are imaging. But we have the tools to make sure that we're imaging at the right resolution and that we're creating the file at the right resolution. But it's best to use a vector-based file format so that you're basically ripping it at the last moment, kind of a thing.
I had one other question. Do you see any applications in biofluidics, and maybe that would go along with the hybrid type of electronics that you were talking about?
Mike, do you want to address this at all?
Sure, I'd be happy to. Yes, as a matter of fact, it was briefly mentioned in Greg's introduction that FlexTech is managing a nanobio consortium, and the actual name is the Nanobio Manufacturing Consortium. So about 2 years ago, the Air Force Research Lab was looking for a consortium that could put together a group of companies who, for lack of a better word, would come up with a smart patch which could be applied to an Air Force personnel and be able to monitor some important functions and be able to tell you if that individual had been injured or they were tired. Some of their cognitive functions perhaps were not as sharp as they could be. Remember that a number of these individuals spend long hours in front of a screen looking at things. So the short story is we put together a proposal, and the Air Force awarded us a $2.5 million agreement to develop a nanobio manufacturing consortium. Now we're working with companies in the bio space, so GE Healthcare is involved, Lockheed Martin is involved, DuPont Industrial Biosystems is involved, the University of Arizona and their medical people, Johns Hopkins University. The underlying platform is going to be flexible printed electronics. And
sorry,
that's okay. The underlying platform is flexible electronics on a conformable substrate, but now you're looking to sample a medium, very likely sweat, in order to be able to tell what is physiologically happening with an individual. So we believe that opens up a whole new space, a whole new market opportunity for flexible electronics, certainly, and very likely a good portion of that is going to be printed electronics.
Interesting. Thank you.
Yeah, you got a question? I got a question for probably both of you. You can answer, separately. I think in these emerging market areas that I've seen in the past that some kind of market education has to happen, right? And it starts even at the ground roots level of actually educating people, to know about how to use printed electronics. But how do you see that? How do you see ways of, besides maybe Cal Poly educating people, of educating the market of how to use these things in different applications?
Well, for FlexTech, in conjunction with our user group survey, we've launched 2 user groups in this area: disposable electronics and wearable electronics. We believe that there is some crossover between those 2 markets. But if you could think of the wearable electronics market, certainly people are talking about smartwatches, but there are things like Fitbits, Google Glass, different types of applications where somebody is wearing now an electronic product on them. In the disposable market, this can go a couple different ways. It could be high-end. So, for example, you've got a sporting event like the Super Bowl or the World Cup, where you want to put something, you want to tag the ticket to make sure that it absolutely cannot be reproduced. I mean, there's no forgeries whatsoever. So, on a $250 ticket, to put a $5 tag is not a big deal. To put a $5 tag on a $2 bag of lettuce, again, changes the economics, and you can't do that. So again, there's a mass market for things that could be consumables, whether they're in the medical realm, whether they're things like fresh fruit and produce. The European Union calls it tracking from farm to fork, is the expression that they like to use. So we believe that there is a mandate for organizations like FlexTech to educate users and potential consumers on what flexible printed electronics can provide.
Wow. Malcolm, you want to take a shot at that yourself from your point of view?
Well, I think quite honestly, we're not as involved in the education of the consumers or the marketing folks. I think really it's organizations like FlexTech Alliance that's doing the yeoman's work there. But having said that, our participation in organizations like FlexTech, we have a lot of interaction with people that are either, in our case, because of our historic background in the printing business, we have a lot of connection to the consumer products goods companies. And so, yeah, we have, we run into the folks at the different shows and have conversations, but that's not really our core mission, truthfully.
No, that makes sense. I was just trying, you guys have different perspectives, so it was kind of interesting to talk about that and see exactly how it could affect the market. I mean, I'm an electrical engineer, but I could see some certain applications, and the supposed iWatch will be out tomorrow, right?
Mm-hmm.
So what they're saying. So I think we could see a lot of applications going wearable. I think here in San Francisco, I've seen a couple Kickstarter projects on wearables that could definitely take advantage of it. One is a smart card, smart business card, which is printed, which I think is interesting. I think this group out of Arizona has developed a smart business card that is disposable in a way, but you can get smart information off of it by just putting it into the USB actually. And then I've seen a couple wearable, as Michael was pointing out, technology, but they're still using, from what I talked to them offline, Kapton tape type of technology. But I think they probably could go lower cost by integrating printed electronics on that technology as well. So yeah, so especially interconnect technology, I think really be interesting. So anyway, if there's no other questions, I thank both of you guys for having this session with us, and especially you, Michael, from the industry point of view, and then Malcolm, Professor Keif, from the educational point of view. So anyway. If you want to get more information, I'll send out to everyone a link to apply for Cal Poly's printed electronics certificate program, and it's http apply.interfolio.com/25181, but I'll send that all to you guys in a little bit, and whoever is actually registered for this. So anyway, thanks for everything. Yeah, go ahead.
Greg,
go ahead,
I might just mention that link is also available on our website, printedelectronics.calpoly.edu, and if you go into the certificate tab, you can click right there and get to that application.
Okay, well, anyway, thanks again. We'll be signing off here, but I appreciate it, and thanks for joining us on the info session for Cal Poly graduate education. So anyway, thanks for joining us. So thanks, Michael. Thanks, Professor Keif.
My pleasure. Thank you.
You're welcome. Good night.